Hi boys and girls, today's lesson is 7.8, adding mixed numbers with unlike denominators, and we will be focusing on some vocabulary terms, mixed number and improper fraction. So please follow along and take notes, and let's do math. All right, today we're just going to review what is a mixed number. So a mixed number, we're going to use these circles, and these circles are going to be our models for mixed numbers. So you have this one, and there's 3 of them, and we are going to shade them to represent 2 wholes. And then we're going to divide the other one into, section it off into sections, making it into a fraction. We're going to create some fractional pieces there, and we're shading in the parts that it represents in our model. And in this case, this represents how many pieces? It equals, if there are 4 pieces, the denominator is 4, and we've shaded 2 of the pieces. So, and then we have our 2 wholes, and if we add our 2 wholes together plus our 2/4, we get 2 and 2/4, representing what's called a mixed number, okay? And you may be able to already see that it's divided into 2 sections, which is half of the circle, so you get 2 1/2. Today that we are going to discuss what is an improper fraction. An improper fraction is a fraction where the numerator is greater or equal to the denominator. All right, so let's look at some models to really illustrate this idea of the improper fraction. So here you have, we're going to call these pies, right? You've got 4 pies. And we need to identify how many pieces are in each pie. So each piece of the pie has 4 pieces in it, okay? And so let's say we are going to represent, we've got each piece, I'm going to shade in here and here, just like that. Okay, so there are 4 pieces in each pie, and there's 4 pieces in each pie, right? And each pie is shaded. This one is shaded 4 times, and this one is 4 times, and this one is 4 times, and this is 1/4. All right? So if we were going to write this as a mixed number, as you've learned, writing it as a mixed number, we would say that this is 1, 2, 3. So we would write it as 3, and then there's only 1 piece of this one, and 3 plus 1/4. So that's what it would look like as a mixed number. As an improper fraction, we are going to write it as we add up all of the parts, okay? And so I'm gonna make our denominator is always 4. We know that because this pie each one has 4 pieces, so the denominator is always 4. And so what we are gonna do is we're gonna add up 4 plus 4 from here, plus 4, plus 1. And that equals 13/4. And that's how you write an improper fraction, right? It's the sum of all of the pieces over how many pieces are in each part. All right, so we're going to talk about how do we add mixed numbers when the denominators are different. Let's first start with our pies. We're going to shade them in, and I'm going to create a problem. Let's say 3 and 1/4. We'll go with that. We'll say there's 1 plus 1 plus 1 plus 1/4. So that equals in mixed numbers is 3 and 1/4. And we are going to add that to this problem, which this problem, let me shade that in for us so it looks all beautiful. And this has 8 pieces, I notice. 1, 2, 3, 4, 5. These are 8s. Okay, so we'll just, kind of remember, how do we represent that? 8/8, 8/8. And then we will have 2 8s there. Okay, that'll be 2 8s here. So if we add these up together, the improper would be 16, 17, 18 8s. But we can visually see that it's 1 plus 1 whole plus 1 whole plus 2 8s. So 18 8s equals 2 and 2/8. This problem is equal to 2 2/8, okay? So we've got our problem. So we want 3 1/4 plus 2 2/8. Well, you know you can't evenly add these together because their denominators are the same. So we're going to have to switch their denominators. So essentially what we're going to be doing, all right, so what we have to do when we know how to change the denominator, but using this model, what we have to do is I have extra 8s. We're going to use the multiple. We know 4 has a multiple of 8. So we are just going to lay these new models on top of the old ones. This one doesn't fit that well. You need to come in and make sure that they're organized like that. And hopefully you can see that this becomes, these pieces become 8s. So this now becomes 8. This becomes 8 over 8, 8 over 8, and 8 over 8. And you will see that this one is now 2/8. Okay, so if we add up all the top numbers, we have 3 times 8 is 24, plus 2 is 26/8, or visually you can see it's 1, 2, 3, 3, and 2/8. Okay, so we can do that now. So now we've got two numbers that can work well together. We've, in model form, we've changed it to be common denominators, and we can just add 3 and 2/8 plus 2 and 2/8, and that is going to equal 5 and 4/8, which equals 5 1/2. And so visually you can see that we have one, hopefully in these pictures, 1, 2, 3, 4, 5, and then 1, 2, 3, 4 pieces, which if you combined these pieces, let's say we chose to do that, right? We are going to combine it, put these two pieces there, you would see visually that we have 5 1/2. Okay, so that's how you add fractions, mixed numbers, when the denominators are not the same, using models. Okay, next what we're going to do is we're going to do the traditional algorithm, and we are going to solve the problem, how do I add mixed numbers when the denominators are different, using the traditional algorithm. So let's do math. All right, well, let's look at this problem now, where we have two fractions that have different denominators. So when you're adding mixed numbers, you can separate the wholes and add them separately at any time because of the commutative property. With your fractions, however, you can also separate those and bring them down and do your working with finding multiples and the common denominators. So let's do that. 7/12 plus 2/3. We know that 12 is a multiple of 3, so we're going to use 12, leave 7/12 as it is. And we know that we can multiply 3 times 4 to get 12, and then we do the same up top, which would give us 8/12. All right, so our new addition problem, it becomes 7/12 plus 8/12, which gives us 15/12. Now, 15/12 is what we call an improper fraction. That is where the top is bigger, the numerator is bigger than the denominator. And so we don't like to leave it like that because it makes it easier to add when we go back to add them together to this whole over here. So we need to convert it. So what do we know? We know 12 over 12 is the same as 1. Okay, so if we take 15/12 and we subtract the whole, which is 12 over 12, that leaves us with 3/12. Okay, so 15/12 is the same as 1 and 3/12. We also know that 3/12 can be simplified, and that 3 is the greatest common factor for both 3 and 12 in this case. So we'll divide by 3 on the top and bottom, which will give us 1/4. So we now know that 15/12 is the same as 1 and 1/4. Okay, and we are going to take that back up to this whole 5 and add that. So it's going to be 5 plus 1 and 1/4. and there's 0 here, so 0 plus 1/4 is 1/4, and 5 plus 1 is 6. So the answer to our problem is 6 1/4. All right, boys and girls, this is, it's your turn. So you show me what you can do. Here are your problems. All right, boys and girls, these are your solutions to those previous problems. And so what do we have to do first? But we have to find common denominators, which when we have 3 and 2, I know that they share 6. 6 is a common multiple of the two of them. And so what are we going to multiply by 3 to get 6? Well, that's 2, and 2 over 2 is going to be what we're going to do, is 4/6. And 3 over 3 was going to be this one, is 3/6. We're going to add them together. 4 plus 3 is 7/6. So that's an improper fraction, and 2 plus 1, that becomes 3. So 3 and 7/6, but we don't want to leave it improper. We have to convert this. So let's take 7/6, and we know 6/6 is the whole. So we're going to subtract 6/6 from there, and that's going to give us 1/6 left over, okay? So we know that we have a 1 whole and 1/6. So this is equal to 1 and 1/6. And then we are going to add that to the 3. Okay, so plus 3, and that will equal 4 and 1/6. So that's your answer there. I wonder if you got that. All right, let's look at this problem. We've got 9ths and 18ths. We know 18 is a multiple of 9, so we're going to multiply the top and bottom here by 2. 4 times 2 is 8. Then we have 8 plus 2 is 10. This one is not going to be improper. And 7 plus 3 is also 10. So are we good to go here? You should have simplified, noting that 10 and 18, their greatest common factor that the two numbers share is 2. So we're going to divide each side by 2, the top and bottom by 2, and 2 goes into 10 5 times. It goes into 18 9 times. And so 5/9 is our simplest form. So we're just going to rewrite our final answer down here, 10 and 5/9. There you go. So your lesson today, your guided practice is here. I just want to point out a couple things where it says estimate and then find each sum. What that basically means is, in your mind, you're looking at this and you're like, well, that's about 2 and this is about 1, so my answer is going to be about 3, right? And then you're going to convert your 8s. We have 7/8, you're just going to write 7 there. And then 4/8 is times 2, so that's 2. And then 7 plus 2, that becomes 9/8. And 1 plus 1 is 2 and 9/8. So if you had estimated you were like 2 here, and this is 1, we're about 3, right? So your estimate was about 3. But the problem is 9/8 is improper, so you have to convert that. So it's really going to be 3 1/8 is your answer. And they really don't give you enough room, and I'm sorry about that, you guys. 3 1/8 is your answer here, and that's close to 3. So that's what it means, estimate, right? But I'm okay with you doing that in your head and just solving it like this. I'm also suggesting today, you guys, to do this, if it was me, I would use explain everything to do your work, because if you aren't familiar with this little fact, you can grab one of these problems. Let's say, for example, you can highlight this like that, and then it breaks it out, say down here, and you can really get it big and work on it. So that's up to you if you want to do it, but I do like to explain everything. So this page, all problems on this page is your work. On this page, there's some good problem solving. This one is a must do here. Let me circle it. Number 19 is a must do. Number 22, number 23, and number 24. These are all fraction related ones. Really fun working. This one was a challenge. I loved it, but it's optional. And this one is not that hard. It's also optional, okay? So must-dos are circled in blue.